big yawns. So many big yawns. It's been a rough night for some people. I'm sure it'll get said a lot. Happy birthday, Destiny. Did you hit the big 1-4 today? Congratulations. Congratulations. All right. So, this is all about modeling fractions and different ways to actually be able to do that. So, first particular portion of the morning is you have a piece of paper. Okay? And yeah, there is a urban myth that basically says it's impossible to fold a piece of paper in half more than 7 times. So your job, first thing this morning, is see if you can disprove that. So I have given you a piece of paper.
Oh.
Fold it as many times as you believe you can.
7.
More than 7 is where we have to go.
That's easy.
Oh, that's easy.
So let's see if you can do it. Did I skip you, Julian?
No.
All right. I gave you a piece of paper. Come on.
I know.
I know. Why are we folding paper, Mr. Bourne?
Because fractions.
It's all about fractions.
And he told us to.
And I asked. You lost count?
2,
Ah.
3, 4.
In half, Julian.
Oh, in half. I'm posting this thing.
Yeah.
Yes, you have to do it in
Oh yeah,
half.
then it's 7 or 8.
Oh my.
Or 8. One of those two.
I can't fold it.
Okay.
Alright.
Cannot
I
fold
can't, I
it.
can't do it. I've done it before.
How far did you get, Quincy? 7. Alexia believes she got to 8.
I think I can get to 8.
I can't fold it anymore though.
You can't fold it
Hold up,
in.
hold up. Yep.
2.
3,
Joseph looked like he just folded up. He got
2.
frustrated.
4.
Nisio's doing something totally different.
5.
He's still not actually participating. But I expect that he will change his tune and start participating the way I asked him to.
So 1,
Relatively
2,
in short order.
3,
There you go. He's unrolling his stuff there.
5.
Tyler's trying to use his palms as a press.
5.
See if he can get that in there.
Another 5.
You can only get 6.
6. Oh my gosh. I need a.
You need to press. You
6.
can get it.
7.
qualifies as 7. I got the 7.
Oh! Kiki says she got 8.
I just got 8
You
too.
got 8. You know how many did you get?
I got
You
8.
got 8.
I got 8.
You got 8.
I don't know what I got. I think I got
Are
7.
you able to hold it down by itself though?
No.
Or just let me rephrase. Is it able to hold down by itself?
No. Do you have a hammer?
Do I have a hammer? I actually do have a hammer. I have 2 different kinds of hammers. I have a regular hammer and I also have a mallet. Alright, so
This will help.
so if I may ask, those of you that seemingly got beyond 7, what happens to the actual piece of paper? Was
It got
actually
hard.
It got hard. Okay. This is actually a science experiment as well. So as something gets smaller, what do you think happens to the material?
It gets harder.
It gets harder. What now?
More compact.
Closer together, more compact. Its density actually semi-increases.
Look at all that.
I mean, y'all have ever seen Ant-Man or Ant-Man and the Wasp?
Yeah.
Batman Avenger? Okay.
Good movie.
So the whole premise behind that particular character in the Marvel Universe is the fact the smaller you get, actually the harder you become. And the more dense you become. So as you kind of fold that paper, the same thing occurs. It becomes harder and harder for you to actually be able to do it. For that matter, it doesn't hold its shape as easily. Yes, ma'am?
I got a home movie, that's what you got.
No. That is not the only thing that goes along with that. But that is one of the premise I want to talk about in regards to size. So, dimensions of the paper. What happens to the dimensions of the paper, you think, as you fold them? It changes how, Denisio? You don't know.
Cut in half, in a way.
Okay, so cuts in half. Would you say it cuts in half of a half of a half of a half? Okay, so that continues down the road until you get basically where you're in. So we're literally on page 45, and I'm kind of helping guide you through some of these things to see what you may or may not realize going forward. So,
I was number 3. As a kid.
yeah, it's number 3. I skipped over number 2. There's a reason why. We'll talk about that here in just a little bit if we have time. As far as 3 is concerned, B, what is the size of the paper ultimately approaching? What would you say?
I say cats.
Cats. It looks like it's yeah.
Cuts in half is what he said, so I'll rephrase it. Let's see, cuts. So if I were to take another scene from Ant-Man, what's happening to his character the smaller he gets?
It gets harder.
He gets stronger.
Well, yeah, there's that, but consider the fact that he continues to get smaller. What happens? Bennett? He continues to shrink. What eventually does take place towards the end of the movie? He completely disappears. Okay? Now, yeah, there's that whole quantum realm. We can get into that conversation a little bit later on. But one of the things that I want to bring out to you is that, yes, every time that it actually shrinks, you're getting closer and closer to 0 as far as size is concerned. Now, that movie, among other things, kind of helps us talk about, well, it doesn't completely always get 0 because you can't just have the absence of matter. Slowly but surely, it's getting smaller and approaching 0. Now, well, it's never actually going to get to 0 because there's always some kind of particles, and at some point in time during the course of the year, in science, you're going to be talking about atoms. And everything is made up of atoms, which makes up molecules, which makes up tissue, etc., so on and so forth. Okay? So, but the smallest particles known to man at the moment in time are called atoms. You really can't see them. Well, you kind of can, and they're like big form, but you need an electron microscope to actually see them. So, can you actually reach the size of 0? No, you can't. Because there's always going to be something in between your fingers that you're going to push again. So, unfold your paper if you would, please. I'll come back to number 2 now. All right? How many regions are there on the piece of paper if there are 0 folds?
0. 3.
1.
1.
Let's go.
There is 1 region. Can you explain why there is 1 region?
Because it's one sheet of paper.
Because it's 1 whole sheet of paper. You haven't actually subdivided it yet. You haven't folded it, so it's 1 whole sheet of paper. So that means the fraction of the original paper is still basically 1 over 1. Okay? If I wanted to sketch it, basically it looks like that. All right? So take a few minutes and finish the rest of that table. Show me what you think. Because you're making a visual representation of what that fraction is. Kind of like what we did, what was that, 3rd day of class together? Give yourself a visual representation of what you're talking about. What's up?
So, like, 1 versus 1 fold, would that be like half?
Correct. Well done.
So you have to do 2 over 1 or just 1 over 2?
1 over 2 because that would be half. We're talking about 1 region of the entire piece of paper.
So the number is 0.5.
The decimal would be 0.5, yes. But the number itself actually is 1/2. So I want you to try to think in terms of fractions today, not so much the other. All right, so come on, sketch artist. Show me what you got.
These boxes aren't big enough.
What do you mean, sir?
You got a sketch inside those?
Yeah. You can do that. I have faith and confidence in you. Now, if you need to refold to see what you got, that's not always a bad thing either. So just a thought.
Yeah, I like to see what other people.
Absolutely, sir. I'm happy to share that with you.
I'll get people over back
Oh,
there.
all right, go for it. You may, sir. But what would it look like as a fraction? That is one of the, like, squares, but what would the whole thing look like as a divided up piece?
So like
Yeah. Like the boxes and stuff.
I don't know what to do for the number of regions on paper. Like, do we put in decimal form on this one or the same thing?
Well, just number of regions, so how many regions are there? If you fold it one time, how many regions are there? No,
Just
two. Okay. Well done, Alexia. So Joseph, what I hear you saying is right here is if there's 1 and a half, so you have one whole piece of paper and a half a sheet.
No, I said it is 0.5.
Well, yeah, but you have 1.5. You weren't wrong when you asked me about the 0.5 part, but now you're telling me there's one whole sheet of paper and a half sheet of paper. So what part would you need to, how many regions are there total? If you have, if this is 1 and a half, how many regions are there total on that piece of paper?
Yeah.
There's only half a region? Maybe? So let's think. Here's my paper, okay? And I'm gonna fold it one time. How many regions are there? 4. Folded it one time. So how many regions are there? 2. I heard something different. I apologize. Please forgive me. So now, if I fold it, so now there's one fold. Now there's 2 folds. So how many regions are there total? Well, congratulations. Keep going. You all right there, Carla?
Mm-hmm.
Are you stuck? Come on, buddy. Let's see, I'm gonna slide this underneath your desk so I don't crush it if I step on it accidentally. How'd you do?
Good.
Okay. If I may ask a loaded question. If you fold it one time, you only have this piece? You only have that piece?
You told it like that, yeah.
Okay. But are you only looking at this piece of the paper?
No, no,
Okay, all right. So describe for me what that looks like. Because what this looks like to me, if I may, this looks like just one piece of tube. So where is the hole? So think in terms of this. Bless you, sir. If this is, that's still, it looks like a piece of paper now, but if I have still the piece of paper and you folded one time, and there are 2 regions, 1, 2. So this is the whole piece. We're talking about one of the 2. do the same thing with this one, this one, this one. So you're basically making the whole box, but how is it subdivided?
Oh.
Okay? That may have been my error. Sometimes I think I'm explaining it correctly and maybe I'm not. All right. I've seen, I think, a total of 3 people that actually have this the way it's supposed to be. So I'm going to pause y'all for just a moment and say, all right, if I fold it one time, how many regions are there? 2. There are 2 regions, okay? So if this is my piece of paper, okay, so this is my whole piece of paper. I now have 2 regions. I've seen a few of you say, well, it's just this. Actually, I've seen a lot of you just do that. So as I told Denisio, I think maybe I did not explain correctly what I was asking for. So consider the piece of paper being the whole piece. After you fold it, what would it look like? And if you need to restart again, we can do that. But so how many pieces, or what's the fraction of one of those pieces? 1/2. Okay. I do have a few people that actually got this, and I'm very proud of you. I'm not disappointed in the rest of you. Just maybe I need to explain it differently. So if I actually fold it twice, how many regions do I have? 4. Well done.
Yeah.
So what does that fraction look like? 1/4. Okay. So now here's my piece of paper again. Now I've got 4 pieces, yes?
Could have done like that.
Absolutely. Okay? Absolutely, because you think about it in terms of this 1/2 first, and then I fold it again. That's where it comes down to. But that gives me pause to think about, I'm going to re-explain this with second period later on. So all of this to say is, what I was asking you to get to is those visual representations of that actual picture. So what does that look like? In terms of a fraction, how would you display that? The last time we were together and we talked about visual representations of fractions, I had a lot of y'all make pies. Kiona made me a pig when it came down to 1. All right? Denisio, I apologize, you were not here for that. But that's one of those things is, hey, how would you visually represent what that looks like overall? And that's what I'm trying to get you to see. All right? So I'm going to move on just in the sake of time. And this is one of those things that I want in your journal. This is something we're going to do a lot. And while, yes, it is in the book, I want this copied inside your journal. This is one of the few things that I am going to make sure that I have you put in your journal. Arrows, etc. If I remember correctly, this is on page 46. 47, thank you very much. So I've skipped over a few things that I find unnecessary and specifically gone to this. This is highly important and beneficial for you. Please copy this in your journal. To the best of your ability. The triangle does not have to be perfect, but what happens around the triangle is really the most important part to me. Thank you, sir. I'm going to ask that you just place it on this page, like you clip it to it. You can get back to it easily. Because when I say we talk about this a lot, we talk about this a lot. And it's important to me that you learn what's being asked of you. Dumb as that may sound. Finished, Joseph? Not quite yet? Okay. First big thing that we really kind of talk about is how to convert between fractions, decimals, and percentages. And before, because you're going to ask me later, both classes ahead of you did the same thing. Well, both years ahead of you asked me the same thing. There is no percentage key on the calculator. Sorry, there isn't one. There's not one way to make it. There's only a way to make a fraction into a decimal, which a lot of you have kind of already figured out in general. Okay? So, but one of the things that you're going to learn to do and you're going to struggle with, you're going to get mad at me. Why am I having to do this? It's because a lot of times you're going to be asked, hey, what is the decimal equivalent to this fraction? Or for that matter, what is this decimal as a fraction? The last piece that you have to kind of manipulate, and that kind of goes back to the whole unit overview, is how do you manipulate numbers and turn them into something else that you need them to be. This triangle kind of talks about that overall. And when I say fractions, decimals, and percentages of families, because they're all a part of the family. They're cousins. Okay? They all may come from a different mom or a different sister or a different dad or a different brother, but they're all cousins. They're all related back to each other. Fractions, 3/10 looks exactly the way the decimal goes. Now, I think it was Friday specifically when I said, hey, place value is something you really need to know. And I would argue, if I ever wanted to go back for my doctorate, that most people in general, the first struggle with math that kind of sets the tone is place value. And if you mess up place value, and if you're taught wrong, or you weren't paying attention, or whatever it may be, or you don't dedicate yourself to figure out what it is, that kind of sets everything else up for failure if you don't get it right. Okay, so knowing where different place values are really helps you overall, especially if somebody writes you a check. You want to make sure they actually give you the right amount that they're supposed to be paying you. So if I want to go one direction or the other, I'm going to go very simply from fraction down to decimals. Basically, I divide the number from the top by whatever the bottom is. Now, here's what happens when you do that with this particular example. In your particular calculator, I want you to divide 3 by 10. 3 divided by 10. And you should get 0.3. Correct?
Yep.
Because 3/10 talks about that place value of tenth. That's the first one on the right-hand side of the decimal. Okay? Simple enough? Okay, simple enough. Now, if I go back the other direction, then basically I'm saying, hey, I'm going to put that number, whatever the actual number is for the decimal, on top of its place value. So, when I say, hey, just read me the number, we'll talk about place value in a little bit. That means this place value in general, this is the tenths place. So it means what it says. So the words tell you what the place value is. So that's 3 over 10, or 3/10. So backwards and forwards, we're talking about, hey, can you do it? But there's another way to do it. Inside your calculator, there's this 2 cool features in 2 different places. If you have a decimal, you can convert to a fraction, and the calculator will help you do that. So, if you have that 0.3 still on your actual calculator, we'll do this again. We're going to do alpha y equals. We do that a lot. So, on your calculator, alpha y equals. This time you're going to go to the 4th option. That's the arrow with the F and the D going back and forth. You hit enter, it's going to say, hey, ANS, is this what you want to do to your answer? Now, if you didn't do that firsthand, you're going to have a little bit of a problem. But if you say yes, it'll convert it back to a fraction. If you already had the fraction there, it'll give you the decimal equivalent, or vice versa. The other way you can do it is if you have that 0.3, or you type in a decimal point and you hit the math button. The first option under math says frac. If you click that option, so you have 0.3 frac, and it converts it back to a fraction. Either way will work, but I also want you to get into the habit of kind of knowing, hey, this is place value. How do I put one on top of another? Now, percentages are a tad trickier. Basically, percentages are based on 100. So the hundredths place literally is 2 places behind the decimal. So if I only have one showing, I honestly only move it 1 time. So 1 time, add the 0, leave it there, throw the percentage on the back side. That's 30. You're done. But think in terms of change. So if you're given a certain amount of change, or for that matter, if you're buying something and it says, I don't know, $3.99, the percentage is actually 399% of a dollar. Okay, so $3.99 over 100 will mean pennies, because how many pennies make a dollar? 100. Okay. I like to teach place value in regards to money. I think it's easier for y'all to kind of relate to, at least until we get back to the thousands place. Then I have to bring in somebody else's currency around the world, and it makes it a little more complicated. But this piece right here, we're going to do a lot with. A whole lot with. I'm going to talk to you about, hey, how do you go from here to there and whatever else. But I'm also going to remind you how to convert with the actual calculator. We good so far? Make sure you use that paper clip I gave you just to kind of clip the actual paper so we can flip to it. If you want to go back to your table of contents and say, hey, Mr. Bourne's picture is really important, this is where it is. That's fine too. But that is going to leave that one to you. All right. Take a look at page, I think it's 47, if I recall. Might be 48, but I think it's 47. 48. So, 48, thank you very much. So, I got this example. I got 0.75. 0.75 is actually 75 hundredths, which means the entire decimal goes over 100, which means the fraction is 75 hundredths. But what percentage is that? 75%. Well done, sir. All right. If we reduce it, it becomes 3/4. So this is my new opportunity to talk to you a little bit about what the fraction, the actual calculator will do for you. So 0.75, type that in your calculator. Go to alpha y equals, option 4. we're going to convert, hit enter. What happens?
3, 4.
3, 4. So, this is another nuance calculator that does it all by itself. It constantly simplifies. Will always simplify. So you've got to be careful with the one thing that I told you just a minute ago. Yes, it's going to convert to a fraction, but then you have to know what the percentage is. So I can't turn that off. There's no way for me to turn that off. Without really complicating your life. So there is a way, if there's an end of the year, if we have time, I might show you how to do it, but honestly, it's not worth it for you to change something in the functionality of the calculator. We're just going to leave it the way it is. So the solution is good, but if you're asked for percentages, you're going to have to know that 3/4 or 3/4 is also 75%. So in your calculator, do these 3/4 on page 48 and write down what you find. If you need help with those steps, please raise your hand, and I'm happy to come assist you. If you want to just do it by hand, that's fine too. You don't have to rely on the calculator, but it is there for you. You okay? Or are you already done? And you're quick. Like it. Good? Okay. Let me see how you focus. Look like your thoughts are kind of swimming in and out of consciousness over here. So, am I losing you? Where'd the Y come from? Oh, okay. Type in your number again. I do forget between the three. There's certain things I have to remember. So alpha, now Y equals. Alpha, Y equals. Option 4. Maybe I should start saying alpha step plot. Sure. Yeah. Quick. Hurry. All right. What do we got? 0.59. Quincy. 59 over 100. All right. Destiny, birthday girl. What about 0.4? What is my fraction? 2 over 5. Which is also what? Well, yeah, it's 2/5. But what is 4/10? Okay, so without simplifying it, I want to make sure that you know both. Okay? Typically, you may not be asked, hey, what's the simplified version of this? It just says, hey, what is the actual fraction? We're going to go from there. All right, Joseph, how about C?
47.
47 over, you said 200? Okay. Which is also what? Think about place value. What is that right there?
94 over 400.
Okay, yeah. Got that part? Very good. 235 over 1,000. Okay, because this is the thousandths place. Well done, Joseph, as far as the simplified version is concerned. But I also want to make sure you know, based on where it sits, what is it over? So the easy way is saying, hey, this is my number. How many places do I have over that number as far as the fraction is concerned? All right, but thank you for the simplified version. Thank you for using the calculator, because I'm sure that's exactly what it told you, right? All right, so we're looking. Come on, Born. Get that straight. All right. Let's see what else you know. This is definitely page 49. So, on number 8, here's my table. We're going to kind of I'll do one of them with you. And I'm going to choose an easy one. So I'm going to do the last one right here. 9/10. What is the decimal form for 9/10? Julian?
0.9.
0.9. Very good. 0.9. And 9/10 as a percentage. Elizabeth, what do you think? 90%. Awesome. All right, so the rest of the table is also for you to fill in. Now, before I lose you with some other things, I need a picture for number 10. All right, a picture of 2/3. And then I want, on number 11, all the other two versions. You got the decimal, I want the fraction, and I want the percentage to go along with it. All right, go.
So we're doing 8 through 12.
Denicio, we are on, yes, 8 through 12. We're on page 49. It's just kind of practice for you. Practice for you. Kyla, don't forget to use that paperclip I gave you. Forgive me, it's going to take a little bit for me to remember that you missed this. Oops, don't break it. So, well done on that one. So now we're going to do 1/10. So, what is 1 divided? You can do this. It'll tell you that part. Beautiful. Or, if we made the fraction, first one, 1/10. But this time I want to convert it. Alpha y equals, now option 4 does the same thing. So either way, but I want to make sure I showed you both ways. Yes.
To make a fraction into a decimal, divide the denominator.
Divide the numerator by the denominator. So whatever's on top divided by the bottom. Or, as I just showed Denicio, you can make the fraction and then do that alpha y equals option 4, and it'll tell you what the decimal is. Both ways work. Look at y'all getting faster. Mm-hmm.
Which one do you need a picture for?
For number 10. Some kind of picture. That's what it means by graphical representation or visual representation. Just some kind of picture. Ah. I don't know what y'all's teachers did to y'all. But man, y'all are faster than last year. I like it.
drop pressure or would you write the answer out?
You can do either one. Either one.
So,
Just want to hear what you think.
for number 10, do you want to select it on the
Yeah,
side?
that's fine. It's there too. Don't worry, it's that. What's wrong?
How do you turn it into a decimal?
Okay, so let's go alpha y equals again. There you go. I'll do the same thing I did a second ago. 4. And hit enter. There you go.
Oh, so I did it for that.
Yeah, so here's what you did. Well, there's that, but here's what you did. You said, hey, 1 divided by 3, so that's going to give you a decimal. So I've got 1 divided by 3, that's my decimal. But what you told it was, hey, I'm going to do that, but I want you to convert it to a fraction. I know this is going to be a decimal. I want you to tell me what the fraction is. So then, yeah, you had to do it again because you told it to do something. Sir? Yes, sir. All right. Let's see. Who thinks 1/10? Joseph, what do you think it looks like? 0.1. What's that percentage, sir? 10%. I like it. All right. What is 0.2, Quincy, as a fraction first? 2/10. That will reduce. Anybody know what to? 1/5. It will reduce to 1/5. All right. So what is the percentage there, Quincy? 20%. Kiki, 25%. What's my fraction?
1/4.
It is indeed 1/4. It's also 25 over 100. So just want to make sure we know both. What is the decimal that goes along with that, ma'am? 0.25. All right. Julian, how about 1/3? I've already got my percentage and I've got my fraction. What is my decimal form? 0.33. There is a repeat on the top. So I know we haven't talked about that just yet, but we're closing in. Got a question?
You always then put the line over since
Thank you. All right, so 1/2. What'd I do? It's really, I mean, everything gets repeated. Typically, you're only supposed to put on the first thing that actually repeats. So I could just be 0.3 repeating, but I've always gotten in the habit of doing 2 places in my own head, so that's just the way I roll. Elysium, how about 1/2?
0.5.
And what-
That's 50%.
Awesome. And 0.6 is my decimal. Eric, what's my fraction? 6/10. Thought I heard a knock. All right. And what is the percentage, sir? 60%. I like it. Man, beautiful. Denicio, 2/3. I already have my percentage as well. What is my actual decimal? Didn't get quite that far. Joseph, what you got?
0.66.
0.66 repeating. Sometimes you will see it as 0.67. Because people just kind of round it up, just FYI. Elizabeth, what's my fraction for 0.75? You got confused there. Okay, I'll come back to you. Kyler, what you got?
I'm not sure.
You're not sure. All right. Alexia, what you got? 3/4. Elizabeth, where was the confusion there?
Well, I was like trying to see something, but then I got like confused with like, 'cause it's hard to explain from here.
Are there people in the hallway?
Yeah.
Yes.
Weird. Okay. What's the percentage of 75 over 100 or 0.75? What's that percentage?
Just
Don't overthink it. What's the number you see? 75. And then what's the percentage? Percent. 75%. All right. Bennett, 80%. Real quick. What's my fraction? 4/5. And what is my decimal? 0.8. Awesome, guys. Y'all are incredible. Have yourself a fabulous